In this video, we will try to find out what is reducible representation and why it is needed. So far, we know the structure of character tables and irreducible representation. If we know the point group and the functions which are closed, then we can find out their irreducible representation. For example, in octahedral point group, if I ask you to find the irreducible representation of dxy, dz, and dzx, you can say they belong to T to G. Also, by following the irreducible characters under T to G, you can say how these orbitals are transformed. You can also say, in octahedral environment, dxy, dz, and dzx form one closed set, whereas dx square minus y square and dz square forms another set, e.g. Therefore, dxy, dz, and dzx behaves differently than dx square minus y square and dz square. This becomes possible as we have known and simple kind of systems. What if we have a more complex system? For example, in a polyatomic molecule, if you are asked to group all the vibrations or you are asked to group all these orbitals, how would you do it? In that case, you will need the help of a reducible representation. In reducible representation, first we extract the nature of the transformation of all the target bases or functions within all the operations of a well-defined molecular point group. Here we do not categorize the functions and neither we grouped them as T to G or e.g. Instead we treat all these functions together. For example, in octahedral point group, we have 5d orbitals such as dxy, dz, dzx, dx square minus y square and dz square. Now, I know nothing about their nature and classifications. Neither I can put them in any group. I will only see how these functions behave under the symmetry operations of the octahedral point group. For that, we will apply each symmetry operations of octahedral point group to the all 5d orbitals and determine their character for each operation. This will give a 5-dimensional reducible representation, which is represented by tau. At this stage, we do not have any information on whether all the 5d orbitals are the same or they may fall under different groups. Then, in the next step, we will reduce the reducible representation using the octahedral point group character table. And by doing so, we can say how many different groups or sets exist for the 5d orbitals in octahedral point group. After reduction, there you will be able to find the tau is grouped into one e.g. and one T to G set. In the next video, we will understand the reducible representation using an example.